is scientifically accurate. What we mean by that is it has been validated against operational data emanating from data loggers on battery electric buses, hydrogen fuel cell electric buses, and natural gas buses. And this data has been provided to us by our transit agencies across North America. So it adds to the scientific prowess that the tool has. Hello everyone, my name is Parvati Pillai and I work as the Program Manager for ZEP Consulting Services and Business Development at the Canadian Urban Transit Research and Innovation Consortium. It's my absolute pleasure that I have the opportunity to talk to you about empowering energy transition, getting to zero emission buses. The web consulting services involves different elements, and you would notice here that QTRIC is able to offer everything from setting the strategic focus in electrification to doing advanced feasibility analysis, considering the predictive performance of a given technology choice on a given transit agency, a service area, to advanced rollout considerations involving cost analysis, benefits, risk, and needs analysis and planning procurement. And after the buses are out on the road, conducting empirical analysis from the data that is, or utilizing the data coming out from the loggers. That all is captured under the rollout planning, and along with which we are offering social consideration analysis from equity perspective, noise pollution, and pandemic considerations as well. So essentially, QTRIC is able to provide all of these services to our transit agency clients. In this presentation here, I would like to highlight the importance of a transit agency planning electrification to consider predictive performance modeling or feasibility assessment as a first step or a second step in our 10-step methodology to go into a full rollout planning or full ZEB implementation. So the tool that QTRIC utilizes is a trademark tool, which is in its second generation right now. We call that tool RoutE. RoutE 2.0 modeling is a very trusted and credible feasibility assessment tool set that has helped multiple transit agencies to predictively assess the performance. There are various features to this particular tool and the deliverables that it produces, but I would highlight a few things here. One of them is the predictive performance success rates that are associated with your chosen technology. So regardless of the ZEB of choice, whether it be battery, electric, or fuel cell, we would look at the revenue and non-revenue operations to calculate what the predicted performance would look like in terms of success rates, and you would get to see some results in the upcoming slides as well. We would conduct scheduling analysis to look at what kind of a downtime or recovery time a given transit agency would have in the schedule to accommodate charging needs that your BEPs would have if they are going to procure battery electric technology. We would also establish the environmental business case by considering the actual GHG emission reductions that are emanating by the replacement of diesel fleet or CNG fleet with zero emission solutions, and assess the suitability with which a block or route can be electrified, and assess the ease of electrification as a whole for the transit agency in question. So that is the beauty of the RoutE feasibility assessment, which is predictive performance, and it has like different facets to it. We follow a finish to start methodology in our work, starting with the GIS modeling, the geographic information system modeling, considering the route profile or the block profile at the relevant transit agency. We look at different transit scenarios, traffic scenarios, the transit schedule, the impediments involved to conduct the GIS modeling, which is a very robust part of our assessment to produce geospatial outputs that get fed into the algorithm to generate duty cycles, offering like a spectrum of possibilities before the client in terms of a theoretical best case energy scenario to the worst case energy scenario. And we consider seasonal variances, different ridership scenarios, etc. in our analysis in creating those spectrum before the agency. We do look at hydrogen and electric bus modeling, in association with which we do look at the CNG, RNG solutions as well. In doing so, we consider different attributes such as auxiliary heating, motor efficiency, battery size, weight of the vehicle, etc. We do in-depth charging analysis, demand charges, volumetric charges, which form the operational cost that the transit agency would need to plan for is all captured in our feasibility assessment as well. When planning for a transit agency electrification and decarbonization, it is important to consider the feasibility assessment. And this slide denotes the milestone projects that QTRIC has helped or QTRIC has performed over the 2020-2021 years. These transit agencies work collaboratively with QTRIC to plan their electrification. We would start on the left-hand side here with TTC. TTC contracted QTRIC to do the partial fleet block-based energy analysis back in 2018, late 2019, and they have commissioned us again to do a full fleet block-based study, and we are incredibly proud to announce that. London Transit is actually a transit agency for whom we have done feasibility assessment in 2020 based on the results of our analysis. They considered all options and they came to us to do a full fleet web implementation planning, and the QTRIC is commissioned to do that as well. With TTC, we would be having the largest feasibility assessment project in the country. With London Transit, we would be employing the most diverse set of variables that a transit agency would need to plan the robust electrification plan in terms of ZEB rollouts, and those two projects are our proud projects that QTRIC is undertaking right now. In the middle, we would see a few other studies that we have had the privilege of working on: RTC, GRT, Grand River Transit, Gulf Transit, the sailboat is Transit Cape Breton in Nova Scotia, and Burlington Transit are all transit agencies across the country who have hired us to plan their electrification in terms of checking whether or not battery electric or fuel cell electric buses would work well and how in their fleet. On the right-hand side, you would notice some Californian transit agencies. We have a strong footprint in California. These are the agencies with whom we have worked in 2020, some of whom have chosen to be QTRIC members as well, because QTRIC is a member-based organization. Right below that, you would notice TransLink, York Region, and Brampton Transit. And these agencies have collaborated with QTRIC on conducting their empirical data analysis, wherein we are looking at the data coming out from the loggers to assess the performance that was previously predicted. And in particular, Brampton Transit is actually an active project that we are undertaking right now for predictive performance modeling as well. On the far left-hand side, you would notice Enbridge logo. Enbridge has commissioned QTRIC to look at zero-emission solution involving compressed natural gas vehicles if there is renewable natural gas in the pipeline. So we are trying to establish that business case based on empirical evidence coming from CNG fleets all across the country and overseas as well. Based on all this, multi-year capabilities that we have demonstrated, Natural Resources Canada has commissioned QTRIC to undertake a study to develop a ZEB rollout process map for the entire country. And we are incredibly proud to partner with Natural Resources Canada to create a process map based on our multi-years of experience in having done rollouts for transit agencies. We have a 10-step methodology, and we are creating a process map which would form a part of a federal standard going forward in electrification. And we are incredibly privileged to have that opportunity to collaborate with NRCan. In terms of a predictive modeling study outcome, I have chosen to compare 3 transit agencies here, and you would notice the Californian Transit Agency. I'm not disclosing the name for proprietary reasons. Same applies to the Canadian agency on the far right-hand side. London Transit Commission results are in the public domain, so the results are shared here. So the first row shows the fleet size, 400, 270 vehicles in total respectively. And the type of study that we did was vehicle-based, wherein we were looking to see whether it is possible to replace the currently operational fossil fuel powered fleet with a chosen zero emission solution in a 1:1 manner or not. The project outcome, wherein we are looking at the success rate under an average operational scenario for weekday services considering 40-foot zero emission buses, whether it be battery, electric, or hydrogen, are given in the third row here. The depot charging for Californian Transit Agency is giving them a success rate of 25% only, which means that with the depot charging, 75% of their fleet cannot be successfully electrified. If they were to complement the depot charging with on-road opportunity charging, they can increase the success rate 70%. However, if they are employing fuel electric bus technology, their success rate based on their operational needs is at 96%. Based on the outcome of this study, this transit agency have decided to pursue the hydrogen pathway, and they are moving in that regard. London Transit Commission, a 200 bus fleet. Based on our analysis, we were finding the depot charging to be at 49%. So a little bit less than 50% of their fleet is only successful with depot only charging. If they complement it with on-road opportunity charging, sure, the success rate goes to 97%. With fuel electric buses, it is at 96 as well. So given the comparative nature of these things, London Transit has contracted Qtrich to do a full ZEB rollout plan, considering both options to decide which one would be the best, given other considerations involved. The Canadian Transit Agency is a 70 bus fleet. Based on our analysis, which was only battery electric buses at this point, we found the depot charging to be hugely unsuccessful because more than 85% of their fleet would be left unelectrified or unsuccessful in electrification. With on-road opportunity charging, they are at 100%. However, in planning their full rollout, they do want to consider fuel electric buses, and they have contracted us to do that as well at this point. This is the same information that I presented previously in the form of a bar graph. Here, you would notice the depot charging success rates are much lower, less than 50% in all cases. With opportunity charging, the success rate have shown considerable degree of improvement. With fuel electric buses, in those two cases that I have highlighted before, also there is considerable degree of improvement above the 80% mark. So I do want to conclude on this particular slide, highlighting the finish to start project pathway that we follow in our work and the quality control, quality assurance, measures involved in place to ensure our clients are getting the right value and the right information to plan their electrification future. From the data collection to GIS analysis, duty cycle, energy consumption, GHG emission, and the cluster analysis wherein we optimize the positioning of the opportunity charges en route. Everything is done in a systematic and scientific manner to ensure the transit agency colleagues are getting the right information and the scientifically neutral and factual information transparently and in a comparative manner, because we have like a whole set of transit agencies that we have modeled. We can even provide the comparative analytics to ensure they are equipped with the right information to plan their electrification future. With that, I would like to thank everyone for tuning into this particular session. Please do let me know if you have any questions. My contact details are here. Thank you so much.